everyone. Today we have our another new episode and we will discuss on advance in Nikola Tesla technologies. We have our world famous speaker, Mr. David Smith. I want to give chance to Mr. David Smith.
Dr. Sharif, thank you so much. Always a pleasure to be on your program and broadcast. Uh, we have had multiple programs on Nikola Tesla, and I will recap some of what you said before, and I think throw some new things in it because I have been digging deeper and deeper into him since we've done some of these broadcasts, um, and have been enjoying it. Now, let me just start back. Is that uh, uh, he was born back in 1856, and he died in the United States in New York on January 7th, 1943. So he has a very interesting background, and he is an inventor and an engineer who discovered and patented many different things like the rotating magnetic field, which is the basis of most alternating current machines thing today. He also developed the three-phase system of electric power transmission and quite a few other things. I mean, he was a prolific inventor and actually tried to patent and tried to protect his IP. But one of his challenges is he was never good at actually commercializing any of his inventions. Um, he immigrated to the United States in 1884, and he sold his patent rights to a system of alternating current dynamos, how it was produced, and transformers and motors to George Westinghouse, uh, who began to take that and push it forward and became this standard that is in use in most of the world today for electric power generation motors. Uh, he competed against Thomas Edison at that time as well, which is kind of interesting. And Thomas Edison, who he worked for a little bit, actually wanted to use direct current versus alternating current. And there have been ongoing patent battles between them and their states for quite a time, where Edison was awarded the patent, and just recently the U.S. Supreme Court overturned that and awarded it back to Nikola Tesla's estate. But his early childhood beginning as a Serbian was real interesting. His father was an Orthodox priest, but his mother was unschooled but very, very intelligent. And as he was growing up, he was taking a lot after his mother and displayed remarkable imagination. And he trained at the Technical University at Garza and at the University of Prague. And he began to work. He saw a early stage of a DC engine, and he reversed it to become an electrical motor, and then conceived a way to use alternating current to his advantage. Also, when he was in Budapest, he visualized the principles of rotating magnetic fields and developed plans for an induction motor that would go a long ways to becoming even the base premise of many of the electric motors used today. Um, and he just continued there. When he arrived in New York in 1884, he was very poor. He had only a little bit of money and calculations for a flying machine. Um, and he, like I said, began to work for Thomas Edison, but the two inventors were far apart in backgrounds and methods, and it didn't work then. But then, like I said, in 1888, George Westinghouse, who was the head of Westinghouse Electric Company in Pittsburgh, bought the patent rights to Tesla's system of alternating currents and dynamos. It begins right into the power struggle between Edison's direct current systems and now the Tesla Westinghouse alternating current approach, which really won out. It was not long after that that Tesla established his own laboratory, where his very inventive, very imagination mind could be given free reins. And he did things like he experimented with what he called shadow graphs, which were similar to X-rays, uh, and works. And there's still debate on whether it was Tesla or Wilhelm Uddin who actually discovered X-rays, but the application of them in the shadow graphs was actually predated the invention by Wilhelm. Uh, and he was one of Tesla's strengths that I found very interesting is that he knew how to promote himself, but he didn't close on many of them. This is when he gave demos of his alternating current, he would do it in his laboratory where he went and lit lamps by allowing electricity to flow through his body, which is pretty good way to show that it could be safe. And then he also invented the Tesla coil back in 1891, which is widely used today in radio and television sets and other electronic equipment. That's also the year that Tesla became a U.S. citizen. And he, like I said, was promoter. Westinghouse used Tesla's alternating current to launch the World Columbian exhibition in Chicago in 1983. And this actually led to the first contract to install power generation machinery at Niagara Falls, which the equipment there carried Tesla's name and patents numbers. And this project carried power to Buffalo, New York. In 1899, he did another real interesting first, and he invented a tele-automatic boat guided by remote control. And he used it and put it together, and he proved his claims for it before a crowd in Madison Square Garden. And so he really was the first one to use wireless remote control to move vehicles around. Uh, he then moved to Colorado, where he established another lab. And in early 1900s, Tesla made what he regarded as one of his most important discovery, terrestrial stationary waves. And what he did by that, he proved that the Earth could be used as a conductor and made to resonate at certain electric frequencies. So he lit 200 lamps without wires from a distance of 25 miles. And then he created a larger Tesla coil, which is so much fun to be around, which produced man-made lightning flashes that measured over 130 feet. And at one time, he was actually proposed that he could receive signals from another planet and that he could transmit power to and from other planets, which was well received in the scientific community. Uh, he returned to New York and began construction on Long Island of a wireless world broadcasting tower with money he got from finance J.P. Morgan. Uh, and he expected to provide worldwide communications and to have a facility for sending pictures, messages, weather warnings, stock reports, and others. Uh, and while he thought this was going to be one of his greatest accomplishments, it was actually Tesla's greatest defeat because it did not move fast enough and JP Morgan withdrew his financing. He then shifted his others project. But because of a lack of funds, like I said, he was not good at commercializing, great at inventing. Ideas to remain in the book and are still being examined by entrepreneurs, scientists, others for unexplored clues and others. In 1915, he was disappointed in a report that he and we're going to share a Nobel Prize. And Tesla, though, was the recipient of the Edison Medal in 1917, which was the highest honor at that time from the IEEE Association. And Tesla was pretty much a private guy, spending most of his time inventing. And he had a way of sensing what the essence of his inventions were, and he would play it again, and refine it in his head before he ever put it down on paper. And uh, so that was part of him. The really other interesting thing is after his death, uh, all of his trunks and his papers and things were impounded and notes and were gone through. And many believe that the government took many of his inventions and developed them in place, like some of the airplane ideas and some of the electronic rays and other things. But they were uh, eventually inherited by his nephew, who later housed them in the Nikola Tesla Museum in Belgrade. Um, and so that is that. The other thing that I find interesting is many times when you're looking at ideas, brings up who references the ones, and find with Nikola Tesla is multiple Nobel Prize winners address part of their tribute to him as one of the outstanding intellects of the world who paved the way for many of the technology developments of modern time. And so you see that going there and being very strongly implemented. Um, a couple of other quick points. We talked about his inventions, and I've talked about a couple already: the AC power, the Tesla coil. He also had the magnifying transmitter, which took a weak signal and boosted it and boosted it. This is what let us get to signal strong enough to cross the ocean. Many of the television transmitters and things like that use that same technology type today, refined more, to be able to broadcast that distance. The Tesla turbine, the shadowgraph, the radio. He invented the neon line. uh, he really pioneered and invented hydroelectric power, not the analog power, which had been in use for thousands of years, but the ability to use his turbines and use the force of water to actually generate electricity, and others. So he was a very, very, very proficient uh, inventor on all of those. Um, like I said, there's some of them. One of my favorites, though, is the Tesla coil, because I have seen that used in so many other places that it's just very interesting how he could take that and revise it, and even how he just to me this day is mind-boggling, in particular when you see it form. The other thing I talked about how he was trying to protect his intellectual property. Uh, Nikola Tesla have filed over 278 patents, uh, and have been very proficient. But the biggest challenge, like I said before, even though he could invent, he did a poor job of selling his ideas to others to help finance them. And he did even a poorer job of actively commercializing any of his ideas. And and that was probably his biggest weakness, if you other, even though his inventions and uh, his ability to innovate have been outstanding, outstanding. Um, he continued to produce a lot of different areas. Um, the relationship with George Westinghouse, though, gave him many different areas where the rights went to Westinghouse, but Nikola Tesla is the genius behind it. One of the most impressive products of the partnership was the Adams Power Station, which was, like I said earlier, the world's first hydroelectric power plant. And it really, Westinghouse and him competing in a competition that was put on by the International Niagara Falls Commission to and there were entries from around the world really to do it, particularly some that Thomas Edison was champion uh, to transmit DC current. Uh, that it was just there. The This station was achieved in 1895 and generated electricity before that. And not after that first one, 10 more generators were built under Nikola Tesla's technology and patents and generated energy. And and the power from those additional 10 was used to electrify New City. So you to see the impact of these and even the design back at the time were the other extraordinary invention he had was one that did not bear fruit at all until 80 years after his death, and this was the Tesla valve. And it was a patent in 1920 of a valve and a conduit who identified a whole lot of new applications for this really a century-old design and things. But this is where his genius was applied to a different area. And the device had no moving parts. It's a series of interconnected teardrop-shaped loops that provide a clear path for the forward flow of liquid, which did not let them reverse flow. And it was used not only electrons like that, it was a device that could moving. Uh, Sharif, there were other things he designed that and worked on that were not as successful. Some of these include uh, he built and tested what he called as an earthquake machine. So in 1893, he patented a steam powered mechanical oscillator that would vibrate up and down at high speeds to generate electricity. And I mean, the stories on this are legendary. Uh, Tesla actually told reporters that one day while trying to use this mechanical oscillator, he was vibrating the building housing it in New York City, and he caused the ground to shake. And as he turned up the power and heard crackling sounds, he suddenly realized that all the heavy machinery in the place was flying around. So he grabbed a hammer and broke his machine. And he believes that the building itself would have collapsed in another few minutes. And police and ambulances arrived on the scene. But Tesla told his assistants to remain quiet and tell the police that it must have been an earthquake. And he did not test it in his lab anymore. Tesla also created what he thought was a thought camera, and he believed it's possible to photograph thoughts. Um, and this was in 1893. He said that he became convinced that a definitive image formed, though, must by when you think about it in your thought, it has to form an image on your retina. And he wanted to build a machine that could read the images that your thoughts formed on your retina. And he also conceived the idea of reflecting an image from your eye and projecting it on an artificial retina. So he was trying to take a photograph of the retina and project it to an image on the screen. And then he said that this way everyone could read their thoughts. Uh, like I said, he also really wanted to pioneer wireless energy. And it's what I find amazing is I know 9 or 10 companies in various parts of the world trying to do that today and successfully demonstrating that. A couple of other of his inventions that were brilliant ideas that never got there is he wanted to build an artificial tidal wave. And he oftentimes looked at military applications of his technology, and he wanted a to build an invention in which the wireless telegraph that he had invented could trigger uh, high explosions at seas that would generate a tidal wave so big that they would capsize entire enemy fleets and turn it over. And he told a newspaper that his artificial tidal waves would make the boats as useless as paper boats that babies float in bathtubs. And then he also, though, later on claims that he had developed some nuclear weapons at the time. He also, from the time he was a young boy, he was fascinated by flight. And he wanted to combine his knowledge of electrical and mechanical engineering to think about aviation after his laboratory was burned down. In an article in 1919, he discussed his work on developing, are you ready for this? A supersonic aircraft that would travel 8 miles above the surface and of the Earth and generate speeds to allow passengers to travel between New York City and London in 3 hours. And his concept, it would be powered by electric motors that were powered by uh, the electricity being wirelessly transmitted using his technology to the from the power plants on the ground and to the airplanes flying, and therefore the aircraft would not need to carry any fuel. And he wanted to do that to airplanes, just like the trains at the time were supplied with electrical energy through rails or wires at this point. And I love that he did this back in 1919. Uh, the supersonic airplane, the Concorde, flew between New York and London in 3 hours. I love that in 1919, Tesla believed he could produce an electric powered supersonic airship that would travel where between New York City and London in 3 hours. So even though he had the idea for the invention using different technologies and using that were actually sustainable, energy efficient, clean technologies. I am just amazed that he was able to uh, forecast the 3 hour time, which was actually the time it took the Concorde to routinely fly that route. One last thing he did that was an invention that really was really different was he continued to spark new visions even late in his life. On his 78th birthday, he told the New York Times that he came up with one of his most important inventions, and he was looking at how to make the world safe and how to eliminate conflicts. But he said this invention would cause armies of millions to drop dead in their tracks. What was that invention? It was a military weapon that would accelerate mercury particles at 48 times the speed of sound inside a vacuum cleaner, and then shoot a high velocity beam of these mercury particles through the free air with such tremendous energy. And this is his quotes: it would bring down a fleet of 10,000 enemy airplanes at a distance of about 250 miles. And even though the press and others at the time called it a death ray, Tesla always referred to it as a peace beam that would foil attacks by airplanes, by navies, by invading armies, and would save lives by acting like an invisible Chinese wall, but only a million times harder to penetrate. And he offered this particle beam weapon to many governments, including the United States, but the only country to show any interest of it was the Soviet Union at the time, which conducted a test way back in 1993. Um, so you can see he was a very proficient inventor, had ideas not in one domain, but many different domains, many different industry verticals, and was way ahead of his time and influenced thousands of people who came after him. Sharif, I hope this is helping here. Let me grab a drink and see where you want me to go. Any other area you want me to focus on, or you want me to keep on going? Sharif, I cannot hear you. Okay, I'll just keep on going then, I guess.
Thank you, Mr. David. With my mind. Actually, through this Nikola Tesla Technology Conference in many economy, we are trying to developing a society. We are focused and we are trying to inspire the young generation for research and innovation. So, in that particular issues, that how you want to guide uh, different universities for doing research and inspire the youth community to be like a Tesla, Nikola Tesla.
Well, Sharif, I love that as a concept, and you know, his his approach to innovation is very centered in his own genius. And he worked, like I said, he defined many of these ideas in his mind and would try to even perfect them in his mind before he reduced it to paper. And that's something that's very difficult to do. What I would tell you is for the new generations of inventors, a new generation of scientists, engineers, entrepreneurs, is go look at his concepts of being creative, not just in one industry, but multiple industries. He was very good about taking ideas he had in one industry and then applying them, the same basic concepts in different ways to other industries. And I think that's one of the things that we do not do enough today because of that. And since our industries have changed so much by digitalization, that we're so transferable now, that's one of the things I would recommend heavily to the students that you're talking about, Sharif. Also, what I would tell you, and I believe he would do this today because we saw that at points in his life, is if he were alive today, I would think that he would be a champion of group intelligence. To me, group intelligence is the multiplier because our problem sets today are sufficiently complicated that oftentimes it takes the minds of many to create optimum solution to move forward. And I believe that applying group intelligence to the youth, the inventors, the scientists, and others would be something that he would totally embrace today and take forward. Uh, Another thing that I would highly recommend is something he tried to do well, and unfortunately uh, didn't have the follow through because he was an inventor and not a businessman. His one of his greatest failures, in my mind, is he never found businessmen to partner with to help him commercialize activity. But Nikola Tesla was very good at trying to protect his intellectual property. Like I said, he filed hundreds and hundreds of patents to protect his property. And uh, even as recently as in this last decade, the court system reaffirmed that the the intellectual property was his, and overturned some false claims against his technology. So to the inventors, his approach to trying to protect his property, his intellectual property, trying to patent it, trying to put the places there is very uh, much something you should do today. The other thing he did, and again, I think this was ahead of his time, is today we call it open source. But he made some of his basic inventions available to anybody to use to improve their products. And I think that's a really important part today of the open source movement we see. And I think part of that goes back to some of the examples that Nikola Tesla set way back then for its doing. And uh, the other thing that was interesting is at the last decades of his life, he worked on new inventions, even as his energy got lower and as the brilliance of his mind began to fade some. And uh, he he was fascinated by neurology, particularly the number three. And he also had a habit that drove people crazy. He was always washing his hands, and and that was there as part of it. But uh, you know, the the politics of the time were interesting. If Nikola Tesla was today, he would be running um, a whole lot of R&D groups for people and making them work in many different ways. The other thing that I think is you will see is he tried to uh, work with many different people, and he was not successful in working with people for a long period of time. And that unfortunately came back and hurt him later in life and things. And um, Tesla, though, as he grew older, also kept trying to write to J.P. Morgan and trying to get further funding and trying to get it. And even after J.P. Morgan died, he continued to write to J.P. Morgan to get funding and trying to work on to develop things. And he was trying to market his patents, but again, he was an inventor and not really a businessman. Uh, and he actually effectively went bankrupt later in his life because of that. And most of his patents at that time had run out, and he was trouble with new inventions he was trying to develop. So you see that going forward. Uh, there have been many claims that he should have been recognized more than he should have been, and that he should have received Nobel Prizes for what he did. But he was given a lot of awards during the time, from uh, awards in his home company. He received medals from the Franken Institute, from the AIEEE. There he received the Grand Cross and other crosses, um, and a medal from the University of Paris. But with the impact of his inventions, the wireless, the remote control of the alternating currents, the hydroelectric power, he should have had many, many more awards than he actually did, and should have been bought there. Um, Also, he even received a patent in the late 20s for a biplane design that was capable of vertical takeoff and landing. And we now have planes that can do that. The planes doing this began to come out in the late 1980s and 90s, But that he patented that technology way back in 1928. Um, and what he did though is he tended to live in hotels and move to different places. And he moved to different hotels every few years. Um, and he also had a very interesting other uh, habits. One of his habits was he loved to feed pigeons, and he thought he could talk and communicate with them. Um, so you see all of those type things going forward. Uh, you know, the other thing is later in his life, actually the Westinghouse company went and started paying for his hotel room and gave him allowances for food and others, and uh, gave him a consulting fee to handle himself. Uh, so that's kind of a lot of about uh, his life, what he did, uh, and was not just an inventor. He was a philosopher. He was a promoter. He was one who thought well beyond his age and and himself. So, like I said, there were about 300 patents worldwide, uh, and some of the patents are still being discovered with people going through his writing and stuff because he patented not in just the United States, but he patented uh, worldwide. And he was a florist. He read everything he could get his hand on. Uh, he also was a lifelong bachelor because he said he wanted to invent and could not do that being married. Uh, and so, like I said, there's a lot you can say around him and about him, but those are some of the characteristics, Dr. Sharif, that I think would be good for uh, inventors, students, scientists, engineers, anywhere in the world to understand the processes and what he did well, to learn from his best practices, and also learn from his worst practices and how to do it different today. So I hope that answered the question.
Thank you. Professor David Smith, what's your concluding remarks for today's session?
Sharif, thank you. I would have loved to see Nikola Tesla alive today and seeing what he could do with all the global resources to information. The fact that the internet has opened up so many sources. The fact that a digital box can go and he tried to do everything on his own, and how even though he's been dead for over 80 years now, uh, his impacts are still felt today, and there's still conferences named for him. There's awards given around the world. There's awards around the world in his name, and there's just so many. Sorry, that I was getting announcements in the background. There's so many places where his impact is so well known and understood that we will be celebrating it in another 100 years as well. I think his inventions have had such a profound impact on the world that he is worthy of study. And like I said, people, they'll go to his archives and read through his writings and his lab books and things. trying to discover other nuances of ideas that can be commercialized and put into effect today. So, Sharif, like I said, I would love to have seen them alive today. But thank you for letting me be part of this.
Thank you. Thank you, Professor David Smith, for your continuous support for World Talent Economy Forum. Thank you, everyone, for joining today's session. Thank you. Bye bye and take care.
Bye bye.